In the last video, we saw that the particles in the atoms of a medium have no role in the propagation of light in that medium, and therefore it is possible that the particles in the atoms of a medium are also not responsible for the slowdown of light speed in that medium. This leads to assume that the photons are interacting with something else other than the electrons or nuclei in the atoms when a photon propagates in a medium. Perhaps the space inside an atom is filled with a form of matter, and maybe the interaction of light with this matter is responsible for the slowdown of light speed in a medium, which causes one of the most interesting phenomena in physics called refraction. Also, Joseph George thinks that the electron-positron pair production, when high energy photons pass near the nucleus of heavy atoms, may be in some ways linked with the presence of this matter in atoms. The current atomic orbital model, or the wave mechanical model of the atom, suggests that the electrons in an atom are situated as matter waves or electron clouds and are in a state of continuous motion. In fact, it is believed that in addition to all other characteristics of an atom, this kind of behavior of the electrons provides an atom its volume. However, Joseph George thinks that possibly the above stated matter is responsible for giving an atom its volume, and he also believes that this new approach to the atom can provide a better understanding and better explanation for most of the phenomena in the atomic and molecular world, including light emission and absorption, bonding between atoms, electricity and magnetism, electron-positron pair production, and so on. According to the present atomic theory, an atom has different energy levels or shells in it, and the electrons in an atom are situated in these energy levels or shells. This theory suggests that an atom emits photon as the result of the transition of an electron from an outer high energy level to inner low energy level, and the energy of the photon will be energy difference between these two energy levels. On the other hand, when an electron absorbs energy, it will transit from an inner low energy level to an outer high energy level. But Joseph George considers the possibility that the electrons in an atom are situated in a kind of resonant columns, which are formed by the above stated matter. Since the space inside an atom is filled with this matter, we can call this matter as space matter. The density of space matter is greater near the nucleus, and it decreases with the increasing distance from the nucleus. These density differences result in the creation of a very large number of thin layers or shells around the nucleus, and each shell has a unique resonant frequency. The resonant frequency of a shell is determined by the density of that shell. Since inner shells have greater densities, they have high frequency resonant frequencies, and because outer shells have lower densities, they have low frequency resonant frequencies. In other words, the frequency of the resonant frequencies of the shells are greater in the inner regions, and it decreases with the increasing distance from the nucleus. The configuration of electrons in an atom is determined by three factors: attraction from the nucleus, buoyant force exerted by space matter, and the repulsion between adjacent electrons. An atom has two types of shells: electron shells and transitory shells. Electron shells are the shells in which the electrons are normally occupied. However, when an electron in a shell is excited, because inner regions have greater densities than outer regions, with the emission of a photon, the electron will be expelled to an outer region. These regions are transitory shells. An electron in an atom can be excited in different ways: collision between atoms, collision by particles, by incident photons, etc. Now let us examine how possibly an atom absorbs and emits a photon. If a photon collides on an electron, which is in an electron shell, and if the photon's frequency matches with the resonant frequency of the electron shell, the photon will be absorbed by the electron, and a new photon with the same frequency of the incident photon will be emitted in a different direction, and the electron will be expelled to an outer transitory shell. If there are no further photon collision, then the electron will fall back to the original electron shell. However, if this expelled electron is simultaneously collided by another photon with a frequency which matches with the resonant frequency of that transitory shell, the electron will again emit a new photon with the same frequency of this new incident photon, and again will be expelled to a more outer transitory shell. Joseph George thinks that in this way we can possibly explain how an atom of an element creates its fingerprint absorption and emission spectrum lines. If you are interested, you can read an article about the structure of the hydrogen atom from the link that is provided in the description. I am Femila Joseph, and thank you for watching.